We're going to solve a projectile motion question. This is an A-level physics question on the topic of two-dimensional motion, and this is on the projectile motion. And as such, I'm going to read the question and we solve it in a simplified manner. You throw a ball at a speed of 25 meters per second at an angle of 40 degrees above horizontal towards the wall. The wall is 22 meters from the release point of the ball. And so here you note that actually this projectile is actually is thrown with this speed, which is 25 meters per second at an angle with the horizontal of 40 degrees. And the wall is 25. This wall here is actually 22 meters. 22 meters from where you have actually from the ball from. And so the first question is as follows: how long does the ball reach the wall? So we are calculating actually the time it will take for this ball to reach the wall. We know that actually this is the solution. The range of the projectile is given by velocity initial multiplied by cos theta multiplied by time. And here we know the range. The range is this distance here. This is the range from there up to there. This is known as the range from the point of throwing the ball up to where it reaches its destination. That's the range. And therefore, the range is actually 22 meters. And we know the velocity initial is actually 25 meters per second. And the angle it makes that makes the horizontal is actually 40 degrees. And the time which we are calculating here, we don't know it. And therefore, we can just here now substitute, merely substitute. So the range is equal to V or cos theta multiplied by time. So which is 22 is equal to 25, which is the speed, cos 40 degrees multiplied by time. So if you make T the subject of formula, you are going to have 22 divided by 25 cos 40 degrees. And now, may I get the answer as actually 1.15 seconds. So this is the time the ball is going to reach the wall. The second question: how far above the release does the ball actually reach before it hits the wall? How far above? So how far above is actually does the ball actually reach? So here we are actually calculating the maximum height. How far above the release does the ball actually hit the wall? So we are looking at this distance here until it reaches that distance. And this is our y0, so this point there. So we can say this is our y1. So this is the height which is being asked that we calculate from this point up to that point. And so we are very familiar with the linear equation where we calculate the displacement, which is for a linear motion, which is actually displacement is equal to initial velocity multiplied by time plus half multiplied by acceleration times t squared. And so here we are aware that this ball is moving in, so our initial velocity here, you are aware is a component, which is the, we have VO cos theta for this component. And going up here, we have VO sin theta. These are the component velocities in the horizontal and the vertical motion. And therefore, we can substitute merely here for the initial velocity here. We are going to have, we have initial velocity times time, and the motion for this moving against the acceleration due to gravity, so it will be minus t squared. And so we're going to have V1 minus V0 is equal to, if you get the vertical component, which is VO for the vertical component, here we're looking at the ball moving upwards. VO sin theta multiplied by time, which is this time minus half g t squared. And therefore, we can make V1, which we are interested in. This one becomes VO plus VO sin theta times t minus half gt squared. And therefore, we know that this one has moved 0 actually above from the horizontal. It has not moved in, therefore this is 0. And then plus, we can now substitute, this is a 25 multiplied by sin 40 multiplied by the time that we calculated, which is 1.15 minus half multiplied by 9.8 multiplied by 1.15 u squared this time. And therefore, what you get as the height above is actually 12 meters. The second equation is number C. What are the horizontal and vertical components of the motion? Remember, we said that the horizontal motion is actually x1 minus x0, which is cos theta multiplied by the time. And for us to get actually what are the horizontal velocity, this is the displacement. We can differentiate dx, dt, dx dt of actually cos theta multiplied by t. So in other words, we can say dx dt, which gives us cos theta, because let's see, now we get the velocity of this, so the velocity, so we are differentiating respect to the time. And this merely actually gives us, which gives us actually VO cos theta. This is the horizontal motion. And if you substituted this, it gives you actually 25 cos 40, which is 19.2 meters per second. And therefore, the horizontal the velocity, the component, the horizontal component velocity is actually 19.2 meters per second. Okay, so what about the vertical component? You remember we just said the displacement going up to be y1 y0, which is equal to actually VO sine theta multiplied by t minus half gt squared. So if you get the differentiate for you to get the velocity, you have to divide dy dt. Okay, so dy dt for this becomes actually, if you differentiate this v sine t, you may get v sine theta. And if you differentiated this one, it becomes actually nearly, it becomes actually gt. And therefore, if you substituted dy dt, it gives you substitute 25 divided by sine 40 minus 9.8 multiplied by the time, which is 1.15. This gives you the velocity dy dt as actually 4.83 meters per second. And therefore, the vertical component the velocity of the projectile is actually 4.83 meters per second. And so the last equation is when the ball hits the wall. So this is actually, these are the component velocities when the vertical and the horizontal, when actually the ball hits the wall at this point here. So this will be the velocity here. Okay, this will be the velocity at which it hits the wall. These are the component velocities. So here the question is just asking the component velocity, but you can find actually the result at velocity. So now, when the ball hits the wall, it hits the wall. Does it reach the maximum or at the highest point? Does it reach the maximum? What when the ball hits the wall, has it passed the highest point? Has it reached the highest point? So no, because at the highest point, the vertical component of the velocity is actually the vertical component velocity at the highest point, the vertical component velocity is actually 0. So we were at that maximum, at the maximum, it's actually 0. So we haven't found the value 0. Also, before the maximum, point before the maximum point. The velocity is supposed to be positive, positive. So meaning that U1 is supposed to be positive. And the value that we found is actually positive. And therefore we can say the ball had not yet reached the highest point. The ball had not yet reached the highest point. The highest point. The highest point. Because it's possible. And therefore, if you want more lessons on projectile motion or any other area of lessons, you can contact me on WhatsApp. Which is +26097419949. Or you can contact me through my email, which is saka@gmail.com. I hope you have enjoyed the lesson. Thank you.